Welcome pre-cal students to the homework help video for this assignment that you see here on the screen in front of you. Please get out your homework, your books, your notes, pens, pencils, calculators, whatever you need, and let's go ahead and get started. Let's take a look first at numbers. Let me make sure I'm on the right page here, which I am not, so hold on one second please. Let's take a look at numbers 49 through 52, the first four. The angles read sketch and calculate the unit vector for the given direction. Okay, sketch and calculate the unit vector for the given direction angle. Okay, so here we go. I'm giving you in problem number 1 a direction angle of pi over 2. Now, pi over 2 of course is 90 degrees. So let's go ahead and get a picture of this. I'm going to rotate from here to here. There's 90 degrees. And the direction said that you're calculating a unit vector. So I know my vector is going to lie on this line right here because I rotated 90 degrees. Okay. Now how far up I want to go up a unit of 1. So we'll say it's this far right here. Okay, there we go. So there's the vector I'm trying to find. It's going the right direction, it's going this way, and it has a length of 1. Now come on students, think about that. If this vector right here has a length of 1, how would I write that as a component vector? Well, it means I went to the left 0, I went to the right 0, so I put a 0 here. I went up 1, so I put a 1 here. And that's the name of that ordered pair, and that's the name of that vector in component form, 0, 1. By the way, if you want to write it as a linear combination, it's totally fine. You could put 0i plus 1j. That would be totally acceptable also, either one of those two answers. Okay, let's take a look at number 50. Okay, pi over 3 is 60 degrees. So let's see what it looks like here. We're going to rotate 60 degrees. So I rotate 60 and I draw a long vector. So there's the direction. Now I know on that line I want to go up so that I have a length of what? Do you remember? A length of 1. So there we go. So I want a length of 1. If I want to find the name of this vector, all that I have to do is draw my right triangle, put 60 degrees inside my triangle because I rotated up 60 degrees. And now remember what to do. All that I have to do to answer this problem is write this vector in component form. All that I have to do is go over so far, that's my x, and go up so far, that's my y. So here we go. Sine of 60 equals opposite over hypotenuse. Cosine of 60 equals adjacent over hypotenuse. Multiply both sides by 1 over here and you're left with sine of 60 equals y. Multiply both sides by 1 over here and you're left with cosine of 60 equals x. Now 60 degrees is one of those angles that's on our table. And if you'll look on your table, you will see the sine of 60 is square root of 3 over 2, so that equals y. And the cosine of 60 is 1/2, so 1/2 equals x. So my x is 1/2. I'm over to the right, so positive 1/2. And I'm up square root of 3 over 2. So there you go. You just found this vector written in component form, okay? All right, moving on to number 51. 4 pi over 3. Now, it's going to be 240 degrees, I believe. Let's see, 60, yes, 240 degrees. So I'm going to rotate 240 degrees. So here we go. Start here, rotate 180 plus 60 more. So there's my direction right there. Now I know I want to come out on this line right here to about right here to where I have a length of 1. Okay, so draw your triangle. Do you see what I'm doing? I draw my direction angle first so I see what direction the vector is moving, and then I know the vector is somewhere on this line, and I know the vector I want is going to come out a length of 1 because it says in the directions find a unit vector. So I come out a length of 1, and now I'm going to simply find my x and my y. Now if I rotated 240 degrees, it's 180 plus 60 more. 180 plus 60 more. So actually it's going to be the exact same thing we had in the last problem, so we'll go back to that in a second and use that. But I know that I'm going to have the sine of 60 equals opposite over hypotenuse, and the cosine of 60 equals adjacent over hypotenuse. Multiply both sides by 1, and I have sine. Actually, I want to stop right there. If you look back at the last problem that we did, right here, we have this formula here, or this equation here, and this equation here, and they're the exact same thing as what we have here. So there's no need to do all this work again. We can see the answer to y is square root of 3 over 2, and the answer to x is 1/2. So the answer to this is square root of 3 over 2. The answer to this right here is 1/2. So my x value going over is 1/2, and my y value going down is square root of 3 over 2. So how would you write this ordered pair in component form? Well, it would look like this. First of all, my x value is to the left, so a negative 1/2, and then my y value is going down, so a negative square root of 3 over 2. And there you go. You just wrote the component form of this unit vector that has this direction angle right here. Alright, number 52, the last one. This will be really easy because it's 270 degrees. So if I'm going to rotate 270 degrees, it puts me right on the y-axis, okay? So I rotate, this is 270 degrees right here. So my direction angle is 270 degrees. I'm going to rotate all the way around to here. So I know the vector I'm looking for is going to be on this line somewhere here, okay? And I know that I'm going to come out a length of 1. So I'm going to come out about this far here, and I'll call that 1. Well, there's really no work to do, is there, students? I mean, if I want to know the name of that ordered pair, I know that I went to the left, 0. I went to the right, 0, so 0. I know I went down 1, so negative 1. Looks like a 7, doesn't it? Negative 1. There we go. So there, you just wrote the name of this vector in component form. Whenever the direction angle falls right on the x or y axis, it really makes the problem a lot easier. Okay? Let me grab a quick drink here. And let's continue on. That was numbers numbers 49 through 52. Let's see what's next. 53 through 61 odd. Okay, here we go. Now, 53 through 58, the directions say to determine the direction angle to the nearest degree. That's all we have to do. So for numbers 53, 55, and 57, all that we're doing is finding the direction angle. Okay, that's it, to the nearest degree. So I'm going to quickly draw my coordinate plane here, and I'm going to make, remember, I make my triangles really big. I don't care about going over exactly 2 or exactly 5 units. I just know it's negative 2, so I'm over this way, negative 5, so I'm down this way, and I draw my triangle. Getting it to scale is not a big deal to me. So there's my vector. I went over 2, down 5. So here's my triangle. This is a length of 2, this is a length of 5, and I want to find this missing angle theta. Okay, so how would I find that angle? Well, I would say tangent of theta equals opposite over adjacent. Alright, so with your calculator, you would now type in second tangent because you are looking for an angle of 5 divided by 2. And if you're doing it correctly, you should get out 68.1, which is 68 degrees. So we're going to change this into an 8 right here, and then put a 6, so 68 degrees. That's not your answer. That's not your answer. Remember, students, direction angles start on the x-axis and rotate to the hypotenuse. So it's 180 degrees plus 68, okay? And you're going to get 248 degrees for that. So the direction angle is 248. Not bad. Moving on to the next problem. Alright, now here they've given us the vector written as a linear combination, which is no big deal. We know that I plus 2j, there's a 1 right here, even though you can't see it. That really just means 1, 2. 1, 2. So I know I'm over 1 and up 2. So I'm going to put my point here, draw my vector, as to which I missed badly. There we go. And so let's go ahead and take a look at our triangle. Draw my triangle over, draw my triangle down. I went over 1, I go up 2, and all that I want to do is find my angle here. So that means tangent of theta equals opposite over adjacent, 2 over 1. We're looking for an angle, so second tangent and then of 2 would give you 63.4 or just 63 degrees. Now, that really is your answer, because if that's 63 degrees and then you start here on the x-axis and you rotate up to the hypotenuse like that, you get 63 degrees. So the direction angle is 63 degrees. All right, let's take a look at number 57. 5, 6. So we know we're going to go over 5 and up 6. So here we go. Over 5, up 6. So my vector is going to be somewhere in this quadrant here. I quickly draw my right triangle. I go over 5, up 6, find theta. Theta would be tangent of theta equals opposite over adjacent. So with your calculator, second tangent, because you're looking for an angle of 6/5 would give you 50.1, or we would just say 50 degrees. Now you start here and you rotate up, so the direction angle would be 50 degrees. Alright, not too bad, guys. Actually pretty simple. Okay, looking at numbers 59, what are we doing? We're doing 59, 61, and 62. So these three problems have the same directions, and the directions read as follows. Find the magnitude and the direction angle. Now this one here is pretty easy, students. There's no work to be done, okay? I mean, you're going to rotate 45 degrees, so you know the direction angle is 45 degrees. And once you rotate 45 degrees, like this, you then know you're going to go out how far? Well, a unit of 3. So you know the magnitude is 3. So I gave that to you just so you're used to that. It's really pretty easy. When the vector is written in that form there, finding the direction angle and the magnitude is just, there's no work at all. You're simply just copying down the information. But now let's take a look at a problem like 61. Let's find the direction angle and the magnitude. So here we go. Now again, I'm not going to draw my triangle perfect. I know I'm going in negative. I'm going to shrink this just a little to give us some more room. I know I'm going over a negative and up a positive, so here's my triangle, or my vector, and then here's my triangle right here. Now I know I'm over 1/2, and I know I'm up square root of 3 over 2. Now before you freak out, find the magnitude of this is really, and that's the two things they want us to do. They want us to find the magnitude and the direction angle. Well, students, the magnitude's not that bad. I mean, look, you simply square root of 3 over 2, and you square 1/2. Now you can use your calculator somewhat, but I don't see a need for you to do that. For example, when you square root of 3 over 2, you're just squaring the top. So when you square the square root of 3, it's just 3. You're squaring the bottom. 2 times 2 is 4. Over here, you're squaring the top, which is 1. 1 times 1 is 1. You're squaring the bottom. 2 times 2 is 4. Add those together. 3 plus 1 is 4. So you get 4 over 4, which is 1, and the square root of 1 is 1. Now, you can use a calculator, but I think it's almost more time consuming because of all the radicals you've got to type in. But anyways, there's the hypotenuse, or the magnitude. It's a length of 1. That really wasn't too bad. Now, whenever you're finding this angle here, you're so used to using tangent, aren't you? Opposite over adjacent. But look, I don't want to mess with the radical when I don't have to, so I'm going to use these two sides. You can use tangent if you want to, but I'm going to use adjacent and hypotenuse. I think that would be easy. Whenever you're using adjacent and hypotenuse, you want to use cosine. So cosine is adjacent over hypotenuse. Well, anything over 1 is just itself. So 1/2 over 1 is just 1/2. So now you're trying to find the angle that when you take the cosine of it, you get 1/2. And that's going to be one of the angles on your table, by the way. If you'll look, you'll see it's 60 degrees. Okay, so the cosine of 60 is 1/2. So inside my triangle here, I'm going to put 60 degrees. That's not your direction angle, is it? No, it is not. It is not. You always start on the x-axis and go to the hypotenuse. So I did not go 180 degrees. I stopped 60 degrees short. That left me at 120 degrees. So there's your direction angle. Your direction angle is 120 degrees and your magnitude is 1. Let's try one more. Okay? -1, -1. Or negative j, negative I, negative j. But really, you understand there's a 1 right here and a 1 right here. So -1i minus 1j is the same thing as -1 comma -1. Alright? So with that in mind, I know I'm going over 1 and down 1. So there we go. There's my vector. There's my right triangle. Over 1 and down 1. Now to find the magnitude, just trust me, you get the square root of 2. I mean, I can do it real quick off to the side. You square the 1, that's a 1. You square the other leg, that would be 1. 1 times 1 is 1. Add them together, you'll get 2. So, using Pythagorean's theorem, we can see right away that the hypotenuse, or the magnitude, or the length is square root of 2. And that's one of the things they wanted us to find, was the magnitude. So we found the magnitude, square root of 2. Now let's find the direction angle, which means we're going to have to find this angle right here inside the triangle. So I'm going to use tangent because I don't want to use a radical. So I'm going to say tangent of theta is opposite over adjacent, 1 over 1. Well, 1 over 1 is just 1. So what angle, and by the way, you're going to find this on your table. What angle do you get when you take the tangent of that angle and it gives you 1? It's 45 degrees. The tangent of 45 degrees is 1. So 45 degrees goes inside the triangle. So the direction angle starts here and it rotates all the way to the hypotenuse. So we go 180 degrees plus 45 more. So your direction angle is 225 degrees. So you found your direction angle and you found your magnitude, which is what the directions asked you to do. So there we go. Moving on. Not too difficult. Okay, next we're going to be doing 63. And let's see, 65, 67, I think that's it. So 3 problems left, not too bad. The last 3 problems say, the directions say, find the angle between the vectors. Find the angle between the vectors to the nearest 1/10 of a degree. So they want us to round to 1 decimal place. Now if you'll look at your notes, the formula you were given was simply this. Cosine of theta equals the dot product of your 2 vectors divided by the magnitude of one vector and the magnitude of the other vector multiplied together. There's the formula. I'm going to go ahead and highlight this so I can cut and paste it for the next 2 problems. And here we go. Well, let's very quickly find the dot product for the numerator. You multiply your first numbers together, 2 times 1, you get 2. Multiply your last numbers together, you get a -20. And we're going to add those 2 together, and we get a -18. So we know our numerator is -18. And now for the top. We very quickly can find the magnitude of each of these vectors. The magnitude of this vector right here, well, square root of, square your 2. That's a 4. Square your -5. That's a 25. Add them together. Square root of 29. And then finding the magnitude of v, we'll do that right over here. Square your 1, that's a 1. Square your 4, that's a 16. Add them together, and you get the square root of 17. So cosine theta. Alright, so with my calculator, I'm very quickly going to type in the square root of 29 times the square root of 17. And you'll get a decimal. I'm just going to cross this off. You will get a decimal of 22.2036031. And now with your calculator, I would type in -18 divided by that number. And you should get something like this, -0.8106792284. And we're looking for an angle, so we're going to hit second cosine of that decimal, and you will get 144.162347, or 144.2. Now yours might be off just a hair depending on where you round it. I'm not going to lose sleep over that. 144.2 degrees. Okay. Wow, not too hard, guys. Pretty simple. Okay, there's the formula we're going to use. Sorry about that. Okay, the numerator says find the dot product. Now, I know it says U and V. We know we're using W and R, so don't worry about that. Okay, let's find the dot product. Multiply your first number times your first number, that's 15. Multiply your second number times your second number, that's 25. Add those together and you'll get 40. So just like that, I know my numerator is 40. Now for the denominator, we're going to find the magnitude of each vector. So let's find the magnitude of W. We'll do that right here. Square your 3, that's 9. Square your 5, that's a 25. Add them together, and you'll get the square root of 34. Okay. Now, vector R, here we go. Let's square 5, you'll get a 25. Let's square 5, you'll get 25. Add them together, and you get the square root of 50. So that's the magnitude of R. With my calculator now, I'm going to very quickly find the square root of 34 times the square root of 50. And if you type that in correctly, you will get somewhat of a decimal like this. And I should have written down my cosine here. I apologize. There we go. Now your decimal will be 41.231055626. So with your calculator, I would type in 40 divided by that decimal. And you should get something like this, very close or identical to 0.9701425001. Okay, and since we're looking for an angle, we're going to hit second cosine of that decimal, and you should get 14.0362, something very close to that. And if you round to the nearest decimal place, the first decimal place, you will get 14.0. Okay? You should be really, really close to that. All right, and the last one, there's our formula. Let's go ahead and find the numerator first, which means we're going to find the dot product of A and B. And by the way, maybe I should slide this down just a little. I hope by now we understand. I mean, we should know that when we see a linear combination, this is a positive. This is 1i plus 1j. That simply means 1 comma 1. And over here, 2i minus 3j just simply means 2 comma negative 3. We learned that yesterday, so I hope that you remember that. Okay, let's go ahead and find the dot product of these two vectors. Well, you multiply your first numbers together, you get a 2. You multiply your second numbers together, you get a negative 3. And you're going to add those two numbers together, as to which you will get a negative 1. A negative 1. So there's your numerator. Now for the denominator, let's find the magnitude. Let's first of all find the magnitude of A. Okay, here's the magnitude of A. You square your 1, that's a 1. Square your 1, that's a 1. Add them together, square root of 2. Now let's find the magnitude of B. You square your 2, that's a 4. You square your negative 3, that's a 9. Add them together, and you get the square root of 13. Now, with my calculator, I'm going to go ahead and take the square root of 2 times the square root of 13. And I'm going to cross this off here. You should get something like 5.099019514. Okay? And so now, with your calculator, I would type in negative 1 divided by that decimal. Don't forget to use the negative number, of course. And you should get something like this. Negative 0.1961161351. And we're looking for an angle, so we're going to hit second cosine of that decimal. And I'm getting 101.3099325, so 101.3 degrees is correct. And as I've done these, I've checked the answers as I went along, and all of them are correct. Okay, so there you go. That's the homework help video for today. I hope that's been a help to you. If you have any questions, don't hesitate to call or email.